Okay, hello everyone. Thank you for coming to this session. So I'm Levent Gurgen from CA. Today I will be talking to you about an open IoT platform which is called sensiNact and which has been recently joined the Eclipse Foundation. It is still in the incubation phase, so we are passing through the IP check and hopefully within a question of weeks we will be available for access to the source code. So I will be talking about that platform plus some deployments that we have done in different collaborative projects so far in some European and Japanese cities. I will follow the following structure. I will start to give you some introduction about why the cities need to be smarter, to give the context of the presentation, and then a little focus on the sensiNact, so the platform that we are talking about. A very brief description of the platform and some deployment examples that we did within this collaborative project. Indeed, we are currently involved around 5-6 collaborative projects in which we have the cities on board, which gives us the opportunity to deploy and test almost real life, let's say, applications by using real life data, which is quite interesting. So I was lucky to coordinate in particular 3 of them. So I will be briefly talking about those projects. And finally, I would like to also talk to you a recent initiative that we are now launching, an Urban Technology Alliance, at the end of the presentation. Okay, so this is just to state that why the cities should be smarter. As you may already heard, more than half of the world population currently lives in the cities. And urban population is increasing, currently around 75% in Europe, around 90% in Japan, for instance. And this is the city is used 75% of the world resources while occupying only 2% of Earth's surfaces. So all of these resources in civil infrastructure, water, energy, roads, public transportation, parking spaces, they should be shared by this increasing population. So we must provide at least the same quality of life and security for the urban citizens, which has direct consequences on the city life. Some other facts, for example, in Europe, 50% of energy consumed today is important and which is expected to increase. European Commission has fixed some targets to handle this. Water, still same situation, huge waste of water due to the leaky pipes, and similarly transportation. We are passing our time to find some parking spaces, which cost us not only environmental point of view, but also economic point of view. So IoT in particular has indeed already the potential to help to deal with all of these challenges. And not only IoT, actually, other types of data sources from the city that can be exploited by integration also with the IoT data, such as social networks data, mobile applications, people just producing data, worldwide web data, and also legacy platforms that already exist in the cities that can have high potential of exploitation, which indeed builds the sensors of the city, let's say. And on top, indeed, we have to build this brain of the city, which will collect that data, will analyze and extract high-level information, and also realize the actions. And the actions that we do, not only making fast actions not sufficient, we have to also measure that the actions that we do, they have desirable effects. So this is the most important point. And then on top of this platform, we can build these citizen-centric services, focusing on different application domains from retail to healthcare to education to transportation, etc. So there are still several technical challenges to be resolved, in particular heterogeneity and interoperability. We see every day new protocol standards appearing, so how we can handle this heterogeneity that we have today. We are talking about billions of devices plus all the big data that are being generated in other information sources, how to handle all of this data. The physical environment is dynamic, so new devices can appear, they can disappear. We are talking about, again, millions of devices. We cannot think about some human administrators that should manage all of these manually, so we have to have some self-management features available in the IoT systems. We are also dealing with the physical world. We have to be careful what we are doing. So even if we need to make rapid prototyping, the applications that we do, they should be dependable. So here, indeed, the model, all about model-based tools, has an important role to play, in my opinion. And without any doubt, security and privacy is another important topic. So how we deal with some of those topics in our sensiNact project. So this is the reality today. We have different types of protocols, devices, platforms as well that are available today in the IoT market and also in the research domain. So we are providing this homogeneous access to all of these heterogeneous protocols, physical IoT protocols, but also platforms with generic APIs that can be used to access on demand to that data periodically, or to the historical data, or event-based. When an interesting event occurs in the environment, we can get notified. And remotely to this platform, we can access by using different types of protocols, RESTful APIs, WebSockets, 1M2M, or other publish subscribe type of protocols like MQTT, XMPP. So the developers, they do not need to deal with all this stuff about communication aspect. We provide the APIs, we provide the data models. We have a service-based model that allows rapidly building applications by using the APIs. And also we are providing a tool that allows them building rapidly applications by using sensor data and also making some actions maybe after doing some processing. So we have this service-oriented approach. Let's say we have the service providers, the communicating nodes provides a certain number of services, and each service is exposed a certain number of resources. This is an example that we show. We have these communicating nodes that are attached, that we attach some sensor interfaces that measure different physical quantities, and also they can make actions. It can be a TV as a sensor. It can be also the remote commander that we interact with the TV that provides the sensor data. And as an action, it can play videos, it can display messages. As this module, as an action, it can send SMS, it can make calls, etc. So all is about resources. And in particular, we have this service model in which, as I mentioned, we have the service provider providing services, exposed resources, and we have this 4 type of resources. We have sensor data, the actions, the main ones, let's say, and then we have the state variables that are modified by those actions that we do, and some property values, which are typically some mainly static information, and then each of these are attached to some attributes and some metadata attached to this information. So we have a kind of a generic extensible model that we can use to model any type of IoT resource, let's say. And then we can access to those different resources by using those different 5 generic, let's say, methods to get at any time information about the properties, sensor data, and state variable in particular, modifying the property value only, because sensor data is the physical environment that modifies this, so we cannot do explicitly modification. And the state variables can only be modified by the actions, which is done by the act method, and then we can subscribe to any of them. We can be notified once there's any modification has been done in these 4 type of resources. So briefly, we have these APIs that is used by developers. So since we have the sensing and actuating services, to build an application becomes a matter of composing those services. You want to make a security application, you compose services a presence detector service, a clock service, or some temperature service that use also services like alarm service or some SMS service that is notifies when some unexpected event occurs in a physical environment, for example. So all about composing those sensing and actuating services. And for this, either the developers can use the APIs to build this, or they can use the this development environment that we propose, which is called sensiNact Studio, based on Eclipse as an Eclipse plugin indeed. And we have a domain-specific language to rapidly build some kind of applications based on an event condition action paradigm. So when an interesting event happens, we verify some conditions, and then we can do some actions. We can go a bit further than typical IFTTT type of things. We can do add some operators that is not. We can dynamically add new operators to the system. For example, you have a specific algorithm of processing some sensor data, so you can it as an operator to the language. For example, here typically we are just checking if two events. So this is about, we detect someone with a presence detector, infrared presence detector service. When it's detected, we turn on the light, otherwise we turn it off. So this one, for example, we have two devices that provide those services. So this is true if and only if these two events are detected in a time window of 3 seconds. So we are sure that two presence detectors detected someone, and there we can be sure that we have someone, and then we do the action. So this kind of things we can do. So we are based on Xtext as using the framework to build the language. So we have used the platform and the studio in different collaborative applications. And used in different cities actually in Europe and in Japan in particular. I will talk a little about this project, so I will quickly pass on that. And doing recently a deployment in Chanrus in ski station in France about detecting the performance of the skiers by using LoRa network, for example. I will also talk a little bit about that. Another EU-Japan project festival, we have some sensors deployed in the train stations. We have also a deployment being done currently in Bordeaux in a wine domain that we will monitor. So it's just started the project. So we will also deploy a LoRa-based network in which we will gather different parameters from the vineyard and also some cellulars. Another more smart home related application also within the EU-Japan project. In Japan we have an experimental smart house in which we have several sensor actuators that we can access, we can control. And also a recently well-aging smart living project in which we will be deploying the platform in about 100 houses in Grenoble area. To provide more autonomy to elderly people, to help them in their daily lives. So this is a kind of the cartography of different collaborative projects in which we are using and developing sensiNact and sensiNact Studio. So this is one project example, as I mentioned. So this project has ended in June last year. So I did the coordination of this project, and it was really interesting to have already two cities on board, Santander city and Genova, and also two cities from the Japanese side, Fujisawa and Mitaka city. We could indeed access about like several thousands of devices already deployed in Santander city that allowed us to gather all of this data and build some applications by using that data. Similarly, in Genova city, we had some environmental sensors deployed, some webcams, some traffic condition type of information, some city displays could be all accessed by using our platform. Another interesting use case was indeed to deploy these air quality detectors on top of some garbage collection trucks in Mitaka city. So we are in real time During the project, there was only 3 cars, but now about, I think, 20 cars are being monitored this way. So with our platform, I mean, you should access at 1 a.m. Here time, because Japan is at 8 a.m. there. At that time, we can see all of this information coming to the platform about the pollen level in the city, about the PM2.5 levels or other CO2 levels, etc. All we can capture from the city. So we had done some other trials in this project, each city focusing on different use cases, so you can have all the information in the project website, which is still alive. So at the end, we could indeed use our platform to gather all of this data and to provide these interfaces to different client sites. Let's say this is our development tool. Some partners use it to make a data mashup tool. Some city dashboard tool has been done, also a small application to make kind of comparison between different cities, part of the project. So we could access about 10,000 physical devices from Santander. Most of them actually are NFC devices, so maybe real nodes, sensor nodes, maybe there are several thousands, but not 10,000 indeed. Some hundred of devices in Genova, and some physical and virtual devices in Fujisawa and Mitaka. So now we have expanded this project from BigClouT to BigClouT, in which we are adding more big data partners in the project. We are aiming at including more intelligence in the close to the edge level, at the gateway level in particular, and if possible in the device level. So we are now going to the second version of the project on top of what has been done in the first project, adding the big data aspect. And having now new cities like Grenoble and also Bristol city in Europe, and from Japan to Tsukuba city. So this is another project that will end in September 2017. So yes, I was the coordinator of the project. I am actually until September, in which we have, the objective was to provide a platform to the experimenters, to researchers, to SMEs, startups, that do not have the necessary investment capacity of having this, a real life experimentation testbed like city environment or home environment, so that we can provide them necessary tools, possibilities to use all of this data for their experiments. Not only IoT, but also we are providing some open data federation. So we are federating Santander data. I mean, by using the same tool, the experimenters can access to Santander data or Lyon data, or we are now adding also from Bordeaux. And besides IoT, we have also IT type of resources included. So the experimenters, they need some computing power, they need some storage to make their experiments. So they can use the platform to get all of these resources. Plus, we have these living lab resources in which we can provide some surveys with the end users to get some real feedback from them about the application ideas, etc. So an experimenter needs all of these, and we are providing this with a unique tool. We have a portal. Indeed, the developers can use this portal to register to the portal, and then to reserve some virtual machines to access to this data by using indeed the sensiNact platform here. And other type of data is available. So the objective of this project is indeed to provide this to the external people, but we also did some internal experiments. Just to give you, yes, this is how the portal looks like. So you can go to the Festival project website. We have also a booth, so you can also see, come and talk with us to how to use the platform. You can discover resources, you can reserve virtual machines, and to base on data which is available, as I mentioned, all the data from Fujisawa, Mitaka city, Santander city, Genova city are all available in the platform. So we have done also some internal experiments. Just very quickly, I think I have, yes, still time. So as I mentioned, we have these physical infrastructures that we provide. We provide the access to those platforms with our tool. We have done some internal experiments about, for example, smart energy management in data centers. So comparing different modeling techniques to better model the energy consumption in data centers. So the researchers in the Osaka University, for example, they could use the platform to gather all this data and run their experiments on top. Similarly, for the smart energy domain, we could also use the platform to access different sensor and actuator available in home environment. By the way, I think yes, we used also Eclipse Smart Home in this experiment. From our side, we also experiment some privacy-friendly cameras. Let's say we are kind of extracting some features from the imagers and only transferring information about the presence or itinerary of the person which is in the scene, and just avoiding transferring images, but some only basic information, which actually in the sensiNact terms, it becomes a presence detector service or a people counting service or heat map service, etc. Another deployment we did is in three train stations in Osaka area, Maya Station, Kamayoke, and Osaka Station, in which we have also sensors measuring different parameters. So this allowed them to compare or to correlate different parameters that they measured about temperature, humidity, different hours, what was the measured values. And the objective is also to they have a kind of smart advertisement type of use case in which, based on different parameters, they can also adapt their digital signages in terms of advertisement based on the physical context. If it rains, for example, a publicity of umbrellas, or if there's pollen level is high, some mask. In Japan, it's quite common to wear some masks, so some mask advertisement, etc. So again, we used sensiNact to gather all of this data from them. Another interesting deployment that we do is in Santander city in a public market. We are using Wi-Fi and Bluetooth for localizing people in the market in order to provide some useful information to the market manager or the municipality about the people flow, how they move in the market, or some personalized offers also in case we use some iBeacons to the people who are in the shop. From the Japanese side as well, we have done some deployments about that. What is one interesting use case is this smart city route recommendation, which shows a bit the exploitation of all of these different type of resources. So we are using the open data type of resources. That this open data from Santander gives information about the available shops in the city center, for example, the bus stations, some bicycle sharing spots. And in addition to this, we have this real-time information about the localization of the buses. We have the information about the offers generated by the shops. We have information about temperature, pollution levels, etc. That allows us to recommend to some tourists, for example, or to citizens as well, to propose them some recommendations based on their profile, based on the physical context of the city, routes to go from one point A to other point B. So we will, in July, we will have a deployment and an experimentation in the city. And last but not least, we have also an experiment from the art domain. So we have an artist in the project that exploits, by connecting to the platform, that use this data to create some artistic effects. He's a video maker, artistic effects to exploit the data and give another perspective to the technology. So the video that he done is available here, and he will be exposing also his performance during the Lyon Fête des Lumières. Maybe some of you knows. He will be projecting his work in Lyon, big buildings in Lyon during this special festival, and with a simultaneous a performance with Japan, because the objective here is that we have two cameras, one in Japan and one in France, and they are being mixed by including also the other type of information like the number of people, the temperature, or the humidity levels around, etc. So as I mentioned, this project is open to external world, so you can join by going to the web page and to register. You can have your credential and you can access and you can start to explore the data that you can use. So if you have any interest or any question, you can find me and I can help you. So there's all information necessary is in the web. So this was the let's say the application that I mentioned about in Champs, so in the French Alps. We will be using as a sensor that detects the performance of the skiers, so how they ski, their speed, how much time they stay over the air, in which speed they go, how they make the movements, etc. Currently, they are using Bluetooth to connect to the mobile phone, and the mobile phone make the application of recommendation, etc. But now the objective is to provide this information to the sensiNact platform by using the LoRa network, and that we can exploit this information. The information can be exploited, for example, by the ski resort managers. It can be exploited also to make some friendly competition between the different skiers. Also some competition between Korean and French skiers, because they joined EU-Korea project. And we will take the opportunity of Winter Olympic Games 2018 in Pyeongchang, and we will make a simultaneous deployment of this in the coming months. Yeah, we will be mainly using LoRa as the communication network, but we will probably be doing some adapters to existing legacy platform of this ski station. So we have also produced a nice video a bit explaining what could be a smart station. So this video also can be accessed at the project web page. So what could be the ideal life or ideal day of a family that is going to ski, and how we can improve their quality of experience. So another EU project in which, just to say you that actually there's Organicity project which can provide a kind of funding to use the platform. So it's about 60 €. That the objective is that for the experimenters that would like to exploit the data provided by these different cities, and by using our platform, they can access to this data and they can use this funding to make some their own experiments based on the data that they can gather. Just a parenthesis here. Yes, this was the use case that I mentioned about the IOF, Internet of Food and Farm. So in Bordeaux, we are making this happen in the coming months with some partners in the Bordeaux region. This also I talk about that. So to summarize the let's say sensiNact feature, we have this device as a service approach, the service-oriented approach, which allows us to be more flexible for adding, removing, updating devices with a minimum impact of the running platform. Modular development and deployment, so we are based on OSGI framework, so we are by nature modular. We have a specified data and service model, which allows us making also open to all about verification by model-driven engineering techniques to build reliable IoT applications. We have this 3 layers architecture, so we believe that we have to, as much as possible, delegate the processing to the device level, and then the gateway level, and finally the cloud level, in order to reduce the network bottleneck in particular. We believe that we have a quite generic and comprehensible data model and APIs, which helps rapidly building IoT applications. So having said all of these, as I mentioned, we have just joined Eclipse, so we have our web page already available. I mean, it's continuously being updated for sure, and hopefully within 1 or 2 weeks, maybe a bit more, we will be available to be downloaded at the page. Sorry. Okay. So I also wanted to talk about this final slide. So all the ecosystem that you saw about the EU, Japanese, and Korean partners, what we want to do is that we want that what we develop becomes sustainable. For this, once the project has ended, we have to have a framework that would continue exploiting what we have reached so far. And we believe also that we have some missing initiative which did not succeed so far to bring together different communities in the smart city domain. So we don't have an initiative in which we have the cities but also technological people. So we would like to create an alliance in which we will bring together all of these actors together in order to allow to the technical people to better understand what they really need, and at the same time to allow the cities to be aware of the latest technologies that these technology providers provide. So these both demand and supply side, we want to bring these actors together based on open solutions, because these cities are now convinced that they need open platforms. They do not want to be locked to some big companies during tens of years. So they want that their local ecosystem also benefit of this openness. There's SME startups. They use the platform to build some innovative applications on top. Even if we know that each city is unique, but at the same time we know that the technical and ecological or business challenges are related and common. So we believe that we have to mutualize the resources and go to exchange of lessons learned and work together to build the cities of the future. We believe that citizens should be in the center of everything, so we are putting this as an important aspect in our initiative. And one of the important points is that we want to build a common language in order that both sides can understand. Because currently, yes, cities are aware of the potential of IoT, but they are a bit confused about what's going on currently. It's going very fast, and many standards actors are trying to get them on board. But they need still to understand really, and they trust to the initiatives that talks about the openness, and they trust, for example, to the institutions like us, which is a independent research institution rather than a large companies. So we have here an important role to play to guide them towards some innovative solutions. So the objective is to bring together all of these different actors, large industries, small ones, cities, and the researchers, and in order to define these cities of the future together. The main objective is to providing this direct contact between, as I mentioned, the city authorities and solution developers, which would be also one-stop showcase for this innovative applications. So the partners will develop end-to-end solutions. They will complete each other's competencies that would not possible otherwise. And another important point is organizing pilot deployment. So the cities will join, and they will open some part of their city. It will depend on the city, large part or smaller part. And from the hardware to the software, the other members will deploy some solutions to showcase the innovativeness. Providing for sure networking possibilities between all of these actors, increase international visibility, and organizing events to exchange best practices, etc. Specific task groups, technical ones, testbed related ones, social ones that will deal with other non-technical issues like ethics, privacy, art, design, etc. As well as the business task group. We have onboard partners that are very important in different ecosystems in Europe, in Japan, in Korea. So we will have all of these links with the existing communities around the world. And we will have different membership possibilities. So just to announce you that we are currently now on discussion with the Eclipse. So we are planning to create a new working group about smart cities. So it will be specifically to smart cities, and it will be a bit different than the existing ones, in which we have, only technology providers mainly. But in this one, we will have also cities on board. We have already confirmation from several cities that wants to be part of this. So hopefully we will be able to finalize the discussions and launch it within I would say beginning of fall, we will be able to officially announce this. So if you are interested in joining us, please let me know. I think this was my last slide. So thank you very much. Any question? Okay.
One is a very small detailed question, and another question, but when you're using LoRa for the ski management,
okay.
Is LoRa able to do real-time tracking of huge volumes of sources?
Not in real time, yeah. Yes. So the rate really depends on how you exploit the network. You have some limitations indeed in terms of frequency. But what we will do is it will be most probably a scale of minutes rather than seconds. That is for sure. And we hope that we will record actually the performance of the skier, and then we will send it a kind of compact data every minute, for instance, in order to have this information. But we will probably not be able to do it in real time, for sure. Yeah.
And the second was about data ownership. For me, this is the first project I see of this size, where you have several cities and with large volumes of sensors and use cases. And I know there's an issue about raw data and process data and who owns what. And you're mentioning privacy a couple of times.
Yeah.
There was a program once about, I think it was a Dutch city that started to work with, I'm sure it was Google, but one of these big cloud-based approaches, let's say, and in the end, the data that belongs to the citizens, you could say, that could be a benefit to your community, is privatized. What is sensiNact or FESTIVAL working on that?
So currently all the data that we provide, they are open data. So we don't provide any personal data except, yes, this in the Active Age project, the elderly people project, that will contain some sensitive data. So this we will not provide for sure openly to everyone. Similarly, for the ski use case, for sure, when the skiers will use it, they will accept a kind of the conditions of using that, and they will accept to the ski resort managers, for example, to exploit the data. If not, so they can have the choice for this. But for sure, this data, some part of data which are sensitive data, they will stay on the platform level and they will have some restricted access. But many of the data that I showed, which are the environmental data about these pollen levels or air conditions or temperatures or parking space, all of these data are open and no issue on that. Yeah.
Still a question. So, who so far has contributed to the development of the platform? Is it just CA or?
So mainly currently the core partner is indeed CA. And because of this issue that so far we did not have the, let's say, the agreement of the openness of the platform, so it was a bit difficult to contribute to the other partners. But now that we are going open, so we will have an increasing number of contributors. In those projects, there had been some contributions in terms of connectivity. For example, there had been some partners that they built this support for additional protocols, because, for example, we had in Japan, we had some specific protocols used by in Japan, actually, like Econet, for example. So the partners, they did this bridge, implemented this bridge. We had some partners, they provide some bridges on the northbound, kind of an interface to send this to some cloud data management interface, CDMI type of server. So the core was only CA, but the partners, they developed some extensions, bridges to those. And by coming now to the Eclipse, so what we hope is indeed that the people are interested in using this and developing with and for, and not only the platform but also the studio. and that we have more contributors. And also the existing partners will now be able to contribute more actively because of now their license issues has been resolved.
I think, I mean, just as a comment, I think it's good that indeed the project is super interesting, but building the community and allowing people to become committers and so on is actually, I think, the real challenge. And, I mean, so what do you think in terms of governance and process to get there? Because CA, I mean, you mentioned that, yes, I completely agree that cities don't want to go with proprietary technologies and be captive of the large commercial vendors. On the other hand, CA is neither a commercial vendor, neither it's still a research center, right? So how do you see the migration now with the governance and building this governance? I guess you're assuming it in the workroom, right?
Yeah. So CA is, for those who do not know, is a large research institution in France. 16,000 people. The CA Tech is the technological research division, 4,000 people, and the mission of CA Tech is the bringing innovation to industry. So we are an applied research center, and only 15% of our budget is coming from the state, and the rest is from the internal industrial collaborations and some collaborative projects. So the objective is indeed that some industrial partners could adopt the platform, or CA also creates startups, spin-offs. That can be also another option. Or the other option is licensing indeed to our industrial partners that add some added value aspects.
But in the context of open source, licensing doesn't make sense, right?
I mean, you can license still to provide some support, maintenance, sure, adding some added value add-ons, new connectivity bridges, or new processing algorithms.
But it's not licensing in this case, it's building the business model around open source.
Yes, but you can also license the whole, right? With some extensions that you can build, or some specific developments that you can do. For example, you can license it and deploy in a CTE environment, and yeah, you can do it. Yes, maybe. Yeah. Okay, I will be around. So if you have any questions, I can answer.